Good morning and a very warm welcome to the 5th Innovation Day of Siemens. I am delighted to see a couple of familiar faces here. Some of you have been here to the various Innovation Days prior to this. So to those of you who've been here, welcome back. And to those of you who are coming for the first time, a very warm welcome to the Siemens 5th Innovation Day. This is just alone in the last 10 years. We have electrified in India more than or equivalent to the entire network of Germany. And this has come just in the last 8 to 10 years. Infrastructure, industry. We are the second largest producers of steel and cement, the third large pharma producing country in the world, and dairy, food and beverage, chemicals are all areas where we are growing and becoming increasingly relevant in the global arena. But digital leadership here has been something that India has been used to. We are digital natives. We have rolled out the fastest rollout of 5G in the world. We have over 1.1 billion mobile users, 954 million internet users. We have the lowest cost of data in the world. And this is actually the basis and the foundation of the growth story of the country. In October, 17 billion payment transactions were done in India. 17 billion. That is 50% of the global payment transactions that were done in 1 month were done here in India. And these are the foundational footprints that Siemens really, or that the country really has, that will be the foundation of the growth story here in the country. But the last 4 or 5 years, the growth story of India has been largely led by government spending in infrastructure, and rightly so. Rightly so, because foundational infrastructure is absolutely critical for the growth in industry, for the growth in digitalization, and for everything else that this country aspires to be as an economic power. In the last 4 years, $400 billion has been cumulatively spent on infrastructure. Roads, bridges, railways, ports, airports. And this has really had an impact downstream into the entire supply chain, which in turn has really contributed to the growth story and to the GDP here in the country. But if we are to sustain 7.5% growth in the country in the years ahead, the government has a very clear program to do that. First, energy will play a critical role. And we are very clearly in the energy transition phase. As I said, 200 gigawatts of renewables have already been created. We expect to get up to 500 gigawatts by 2030 and to 600 by 2032. And we are well on track to do that. But that will have a knock-on impact onto the entire transmission and distribution networks in the country. As you bring more renewables into the grid becomes unstable. As you grow as an economy, you will need more grids, you will need a better distribution system. The country is looking at doubling not only its generation capacity, but doubling its transmission, and will have to therefore double its distribution capacities in the next 5 years. And we are well on track to do that. Technology will be the absolute enabler, will be the key imperative to take us to the next level. But as I said, technology is moving at a pace much faster. And in the meantime, we have a whole lot and a whole host of new technologies that are acting as further enablers to make this platform even more powerful.
One key question that we have to start with asking, and that is, what if? What if is a very powerful question because it lets us think in different ways. Let me start with something very near and dear to your heart, which is actually also near and dear to my heart. That is, if you take some nice spices and combine it with black tea and a little bit of milk, you get to, of course, a warm, delicious cup of chai tea, which I very much enjoyed also this morning, which is a great invention and innovation coming out of India. So, what if you actually are looking to a standardized solution to improve food and beverage production around the world? If you today in food and beverage, you're going to face a few challenges. One of which is there's a lot of increase in prices, energy prices, harvest prices, all of these are going up, while your consumers are not willing to pay more. So sustainability, you have to prove that you're actually certified and that you can track and trace all the different elements that you're shipping. And then lastly, there's sustainability as well, where it's all about biodiversity. Your consumers want to have always the same taste, while the input or the grain and the different materials that you're using is actually changing because of the different forces that we see in nature. So what if we can help you actually to standardize it and to make your life much, much simpler? What we've done here in this case is for dairy production. And this is where we used Industrial Operations X to help dairy producers to produce their milk powder that requires a lot of energy. So the way you produce milk powder is pretty simple. You take dairy, you apply a lot of hot air for a longer period of time, and then out comes the milk powder. But turns out this is a very energy-intensive process. So what if we can help you actually to reduce the energy consumption by more than 10% and improve the throughput at the same time by 10%? And the way we did this is by building a digital twin of that very production. So we precisely simulated the entire production process step by step, based on conventional but also on digital models, which enabled us to run multiple what-if scenarios and identify the key parameters in order to fine-tune the model to make that work. And you can tell, obviously, it is paying off, not just from a bottom line with regards to the P&L, but also from an energy and sustainability perspective. This is very, very powerful. Then what if about data centers? And probably everybody nowadays is talking about data centers in two different ways. Because for one, they're part of the solution. There's an estimate study that says about 40% of all the energy can be reduced if you use actually data. So then data centers are part of the solution. But there's also studies that suggest that data centers are part of the problem because 4 to 5% of global greenhouse gas emissions are emerging out of data centers. And the tendency is increasing because of all the large language models and the AI now finding its way into data centers. So therefore then, what if we could make those data centers more efficient, make it more sustainable, but also make it safer in that regard? And here, I would like to take you actually this time outside of India into a cold place called Estonia. And Estonia has built one of the finest data centers that is out there with green energy that actually is not only the safest, but also is about one of the most sustainable ones. It is a data center that consumes 31 or 32 megawatts which is quite substantial if you think about it. It can power actually a small city in that regard. And what we realized is that about up to 40% of all the energy consumed by a data center is in cooling and ventilation. So therefore, if you are able to create heat maps, literally heat maps, of that very data center, if you can build a digital twin to understand where the power is disseminating and what kind of cooling that is required at which part of the data center, at which point of the day, you can significantly reduce the amounts of energy that is being reduced. And of course, if you take that excess capacity or the excess heat and put it back to a heating company, then of course you can save a lot of money. And that's exactly what we've done, that in order to apply that, we have to bring the sensors, we have to bring the digital twins into it in order to make it much, much more efficient. So let me conclude there that we, of course, want to bring technology to make our lives easier. And with asking what-if questions, we can turn complex challenges into actually quite manageable tasks and distill them down. We want to build a more competitive industry, which is much more CO2 neutral, and where our lives are becoming much, much better. It's quite simple. All what we do is we have to work together, because in the end, it's not technology that makes the difference, it's the people that use the technology to make that very difference. And all what you need to do is by asking one very simple question, and that is, what if?
How we use some of these technologies in our own lives, because that's the best way of getting benefits from our own technology. Also to see how these and give feedback to our developers, our R&D organizations on the real world and how these technologies are impacting life as we manufacture. And the third most important thing is these are not just for big companies out there in the global world, but also relevant for small and mid-sized companies, mid-sized businesses operating in India. The example of our operations 25 kilometers from here in Kalwa, I think, is well known to a lot of you because it's been in the press and the media for a long, long time. But just for people who are still not aware, this was a factory which was being challenged as to whether we continue its operations a couple of decades back. And what we could do here using our own technologies and using digitalization was phenomenal. We actually, I will not get into the details, but the output grew 35% from 1.1 million pieces to 1.5 million pieces per year. 22 different variants on 3 lines got transformed to 350 plus variants of products on a single line. Cycle time reduction from 21 seconds to 9 seconds. 22 different quality parameters measured in 60-second cycles to 68 quality parameters measured in 9 seconds, and above all, about 400 megawatt hour of energy saved, and hence reducing the carbon footprint.
When we get into the digital transformation, it is just not buying a product, it's not a buying solution, but it is also about change in the mindset. We are introducing around 2 products on an average in a month. We developed the entire line in the digital world. We simulated, we did all the what-if analysis over there. We built the line, and after testing the line in the digital world, we implemented the line on the shop floor. And I must say, the benefit what we got. The first major benefit is we completed the project 3 months ahead of the time schedule. Second, we could reduce the cost, the planned cost, by 12%. And the last is we designed this line with 0 manufacturing defects, first time right. Just last year, while we were growing, our energy consumption came down by 3%. Now these 3%, if I connect it with the growth, our specific energy consumption per device actually came down by 20%. We did a benchmarking in FY 2021, and with respect to that benchmarking, we have reduced our energy consumption in actual by 12%, and if I convert it onto the specific energy consumption per device, we have reduced it by 40%. Using technology, we should also have a bigger impact. And what we are planning next is to take these learnings to the wider ecosystem and have all our supplier partners also integrated into this, and we take our benefits to them. And I want to make a statement. We want to have the future supply chain physically apart but digitally connected.
Industry, at the one hand, is the major driver for our wealth. It's responsible for almost 1/3 of our GDP, but without industry, we won't have a nice life. The chairs you sit on is made by industries. The clothes you wear is made by industries. The glasses you have, the phones you talk to, which I talked before, the food you eat, the vaccines you got, it's all industry. So it's really, really important driver for our wealth and our well-being. So the real challenge for industry is how do I adapt fast? It's all about becoming faster. That's, by the way, why we call our platform Siemens Accelerator, because we promise we will make our customers, you and our partners, faster. So how do you get faster? How do you get faster in industry? And we believe the biggest driver for getting faster in industry, which is an asset-driven, it's an asset-driven thing, is use software. You need to move at the speed of software, and that's why we talk so often about digitalization. Because if you're in the real world, you can be 10 times, 100 times, a million times faster simply because you don't have to obey to the laws of physics, which happens in industry. Because I can use the power of the cloud. All the data I can simulate. The only limitation I have is how much compute is available. And when we talk about these fancy words like digital twins, it means nothing else that you have a notion of physical assets that you can simulate and describe, and physical processes, and then do stuff much faster, much more resource efficient. The only thing you need is electricity for the data centers. And that's, by the way, why you go to the Nordic regions, not because we don't pollute, because there you get green energy as abundance. So there you can afford to have really green data centers. So how do I reduce effort? And how can I increase usage? And I give you two examples of what we can do to reduce effort. One is, how can you actually build models that you have to share with somebody else? And let's start with this. And the magic here is that you can train models independently, distributed. And instead of sharing the data behind the models, you only have to share the models. So and then you do aggregates of models. It's called distributed and federated learning. And we did this for our own factory network. And we had fantastic results because it also makes it much cheaper because you don't have to move the data and pay for all the transition. So federated learning is something which is really, really good if you also work with a network of customers and partners who don't want to open up their IP, but they're okay of sharing the models, which at the end of the day can also protect your IP. When it comes to sparse data, there are other strategies. One of them is synthetic data. Because instead of measuring, you simulate. The problem is you need to understand the real world. You need to understand mechanics, thermodynamics, electrics, chemistry, and guess what? Siemens is #1 in engineering. We have a fantastic portfolio, a simulation portfolio, and that is, of course, what we were using here ourselves when saying is you can now have physics-based models that create high-fidelity data that's as good as if you were measuring in the real world to train some of your models, like we did in this case with Suprakash, and that's a photorealistic rendering which can then help you train the models even though you can't measure it yourself. Another thing is there are certain problems you can't even program. You can't program a complex, which you think is a very simple thing, like I have a conveyor belt, 3 different conveyor belts at different speeds, packets are coming in, and typically when you see sorting, big thing in India, big thing in China, is you want the packets coming equidistant out of it. Try to solve this numerically and algorithmically. It's almost impossible. But with reinforcement learning, again, using synthetic data, very easy to do. Takes less than 2.5 days to do this entire thing instead of potentially years of trying to find an algorithm that might or might not work. And last but not least, and I talked about this before, is physics-based AI. In this case, we talk about computational fluid dynamics. It's the simulation how air is flowing around, for example, a car or a train or an airplane to reduce drag, again, save energy. Make it faster so that you don't have to put more power into propulsing it. And these computational fluid dynamic simulations like Star CCM Plus from Siemens, they take quite a lot of time. But if you build AI-based surrogate models, which are trained in a lot of the scenarios, you can get the same result or almost the same results in seconds. So that is a massive game changer because now an engineer, if this is built in, for example, in our engineering tool like NX, they can change geometry and can immediately see, is it better or worse, instead of they have to wait days for the simulation and spend a lot of money. Another thing was, of course, is how do I make AI more accessible? Because normally you have to have data science, they need to understand all the algorithmic, they need to understand all the models and build it. And a simple thing which every human being can do, grasping a piece which you have never seen before, and if you try to teach this a robot, again, it's impossible to do this algorithmic. You need AI for this. And when you go outside, just 2 rooms to the next, you see something called the robot Pick AI, which was pre-trained on more than 200 models. So in order to do that, you don't need one AI model, you need 200 different ones, aggregated. Again, we trained this a lot. We talked about digital metaverse. So in the metaverse with our synthetic data, and now this robot AI can do what no human being what human beings can do as well, which you've seen. It can anticipate what you wanted to do, find every part. So check it out just to see what are those applications that you can have in the real world. That's all I wanted to share with you. So with that, I leave you hopefully with a little bit of thought. And what can you do, A, to contribute to the data challenge, and how can you benefit from it? Visit the stands outside. There's a lot of what I explained in real world that you can see how it's actually happening. With that, thank you very much for your attention.
If you like the video, do like, comment, share and subscribe.